Today I will be showing you a quick way to measure and verify the slew rate of a DC electronic load. As you may know, the slew rate is a performance specification that indicates the responsiveness of a DC load under dynamically changing conditions. In general, it is measured based on the maximum current range the load is capable of sinking. Between the 10% and 90% region of a load's change, the slew rate can be measured by observing the steepest slope portion, as indicated by the graph. The indicated measure time will be used to calculate the slew rate. Hence, the slew rate calculation is simply the difference in the load change, in this case rated max current minus 0 amp, all over T, where T is the measured time from 10% to 90% region, and rated max current is the specified maximum current of the load under test. In order to measure slew rate of a DC load, you need to have the following: a DC load, a power supply capable of producing the maximum current that can be drawn by the load, a shunt resistor, a digital storage oscilloscope, and test leads that can handle the maximum current to be drawn. For demonstration, I have a setup here to measure slew rate of a BK Precision 8502 DC electronic load. Here I have a BNC to banana plugs cable connected to a DSO, with the banana plugs connected to a shunt resistor rated for approximately 66 milliohms, 15 amps. If you are testing with higher current, use a larger shunt. Connect the test lead from the positive terminal of your power supply to one end of the shunt resistor. Then connect the positive terminal of the DC load to the other end of the shunt resistor. Now with another test lead, connect together the negative terminals of the power supply and the DC load. Your setup should look like this diagram. Now we need to configure all the instruments for the setup to measure properly. On the power supply, set the output voltage to 20 volts and the current limit to slightly above 15 amps so that the power supply can maintain a constant voltage mode at maximum current draw by the load. For the DC load, some electronic loads have a toggle transient feature or some way to control adjusting from one level to another quickly. With BK Precision's 8502, we will set the load into transient mode and use the toggle feature, setting the levels to toggle between 0 and 15 amps. On the oscilloscope, set up to use manual trigger. I'm going to set it up to do a single capture. From the trigger menu, change the mode setting to single capture. Now it will look for a signal to trigger off of and capture a single screenshot. Turn on the power supply's output and then turn on the DC load inputs. Now I'm going to push the trigger button on the load to toggle between 0 amp and 15 amp. As soon as it toggles, it will capture a signal on the scope. We are going to focus on this shot to measure slew rate. Now use the cursors from the oscilloscope to trace the 10% and the 90% mark of the slope transition. The difference between these 2 points equate to 12 amp because 90% of 15 amp is 13.5 and 10% is 1.5. Subtracting the two equals to 12 amps. Make note of the time difference between the 2 points. Here, my cursor time difference is measured to be about 24 microseconds. Divide 12 amp over 24 microseconds and you will get a slew rate of 0.5 amps per microsecond, which is what the 8502 is rated for. It is important to note that while we define slew rate to be from a change of 0 to 100% of the load's maximum input current, slew rate may vary if measured with a different transition range, such as 20 to 50%. Keep this in mind and measure your slew rate accordingly based on your application.